Hello, I am Lu Yui from Institute of Computing Technology. I am pleased to present my paper titled A Category Agnostic Model for Visual Rearrangement. This paper focuses on the visual rearrangement task, which can help an embodied agent to physically recover the shuffled scene configuration to the goal configuration. Previous methods usually follow a similar architecture, using a pre-trained detector to assign category labels to each object and infer the rearrangement goals through matching the semantic scene graphs of both the goal and shuffled configuration. However, the inference of category labels not only causes the accuracy drop of the entire task, but also limits the application in real-world scenario. In this case, our motivation is to identify all scene changes in the room and restore them, regardless of any category. We present a modular approach to tackle the task, decomposing it into manageable subtasks including visual exploration, scene change detection, and scene change matching. For visual exploration, we propose a closer-aligned-retrace exploration policy, aiming to observe more objects at a closer distance to improve the observation accuracy and completeness. We build an observation distance map, where each grid denotes the minimum distance at which the current coordinate point is observed by the agent. Through the optimization of this map, the agent can be guided to observe objects closer. In Scene Change Detection module, we compare the point clouds corresponding to the goal configuration and the shuffled configuration of the scene, recording the moved part and the protruding part to construct the diff cloud, which encompasses changes in all areas of the scene. To recover the scene configuration, we need to match changes across various locations in the scene. Since the diff cloud contains only some points in space, we first extract the entity layer information from it, and then perform scene change matching on the entity level depending on the similarity of category agnostic appearance feature. This process can be regarded as the weighted bipartite graph matching. After the matching process, we obtain a series of rearrangement goals with their goal states and shuffled state. Subsequently, for the inferred rearrangement goals, we transport them to their goal states in succession, during which we leverage the 2D obstacle map and Dijkstra algorithm to conduct obstacle avoidance and navigation path planning. In original RoomR dataset, the spatial range of object changes is limited due to the confined area with single room scenes, and the target objects to be rearranged are mainly category-wise, i.e., most categories only have one instance. To cater for the prevalent characteristics of indoor environments in reality, we build a more practical and challenging dataset MrMiR for the two-stage rearrangement task on the AIT2THOR simulator, where the change in the state of an object can involve a broader spatial range, even extending across different rooms. Besides, there exists multiple instances within the same category that have different appearance. We report the quantitative comparisons on the RoomR dataset in Table 1 and the MrMiR dataset in Table 2 with the two state-of-the-art modular methods, mass and tidy. The experimental results demonstrate the effectiveness of our proposed method.